When headlines scream about a Chinese attack on Taiwan, they fixate entirely on one thing: semiconductors. They tell you the world economy will collapse because no more chips are made in Silicon Island. But that narrative is dangerously incomplete and misses the real trigger for global disaster. The actual fault line does not begin with silicon wafers or fabrication plants. It begins with energy, food, and shipping logistics collapsing within days of a blockade. By the time anyone notices a chip shortage, the world will already be deep in recession because the arteries that feed modern civilization have been cut. This is where Western strategy has fundamentally failed to account for immediate physical constraints. We obsess over high-tech sovereignty while ignoring the brittle architecture that keeps our lights on and our tables full during a crisis. The assumption that we can simply wait out a conflict until supply chains reroute ignores the reality of just-in-time optimization gone wrong. Global trade runs on razor-thin margins where efficiency is king, but in war, efficiency becomes a liability. A single blockade at the Taiwan Strait does not stop one industry. It severs the lifeline for everything built upon that flow of goods and fuel. Consider how deeply dependent modern economies are on continuous maritime movement. The global shipping network operates with almost no redundancy for critical mass commodities like liquefied natural gas, grain, or refined petroleum products. These are not items we can stockpile indefinitely in warehouses because they require constant temperature control or have limited shelf life. When the strait closes, ships cannot simply turn around and reroute through other choke points without massive delays that ripple outward instantly. The result is a sudden scarcity of essential inputs for power generation and agriculture across Asia, Europe, and North America simultaneously. The strategic failure lies in prioritizing chip autonomy over logistics sovereignty. Policymakers spent the last decade pouring billions into semiconductor manufacturing hubs like Arizona or Saxony because they believed chips were the ultimate bottleneck. They treated high-tech goods as the fragile linchpin of global stability while assuming energy and food flows would remain resilient enough to absorb a shock. This is a fatal miscalculation based on a false hierarchy of needs in wartime conditions. You can survive without advanced microprocessors for weeks, but you cannot run an economy without natural gas or wheat imports when demand outstrips local supply by orders of magnitude. Quick resource note: I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. Imagine the immediate aftermath of a blockade as a cascade failure rather than a single point of impact. The first wave hits energy markets within 48 hours because refineries and power plants rely on imported feedstocks that no longer arrive. Prices spike not gradually but vertically, forcing industrial shutdowns across heavy manufacturing sectors like steel production, chemical processing, and automotive assembly. These industries do not just slow down, they halt entirely because the cost of fuel becomes prohibitive or physically unavailable. The ripple effect is immediate: factories close, workers are laid off, and demand for all other goods evaporates before a single chip factory even considers shutting its lines. This creates a feedback loop where economic contraction accelerates faster than any supply chain model predicted. A study on the impact of global crises suggests that small to medium enterprises face internal versus external pressures that can tip them into insolvency within weeks when input costs double or triple overnight. In this scenario, it is not just large corporations struggling, it is the entire ecosystem of suppliers and service providers collapsing under the weight of energy price shocks. The decoupling happens because there are no alternative routes for bulk commodities during a high-intensity conflict zone that controls the world's most critical maritime corridor. Now consider the difference between chip shortages and commodity collapses in terms of recovery time. If Taiwan stops making chips, it takes months or years to build new fabs elsewhere. But if energy prices spike by 200% due to a blockade, the damage is done instantly because no amount of capital investment can fix a missing shipment overnight. The world economy does not have enough strategic reserves for natural gas or grain to last through even a short-term disruption without triggering panic buying and hoarding behaviors that further drive up costs. This creates a self-reinforcing spiral where scarcity drives inflation, which drives recession, which reduces demand further but fails to lower prices because the supply is physically blocked from moving. The real production failure mode here is the lack of modular logistics networks capable of rerouting around single choke points for critical mass commodities. Software-defined supply chains have made great strides in tracking containers and optimizing routes for consumer goods, but they have yet to fully implement redundancy protocols for energy food security at scale. We optimized for cost efficiency over decades until we had no slack left in the system for emergencies. When a crisis hits that requires physical rerouting rather than digital optimization, our infrastructure simply does not have the flexibility to adapt quickly enough to prevent systemic shock. This brings us back to the core insight. The immediate decoupling of essential commodities is far more catastrophic than any semiconductor disruption because it strikes at the foundation of economic activity itself. A chip shortage slows down production. A fuel or food blockade stops production entirely and creates social instability that no amount of technological sovereignty can resolve. The United States and Europe have built systems designed to handle market fluctuations but not physical blockades on critical infrastructure flows. We assumed our globalized just-in-time model was robust enough, ignoring the fact that war changes all rules of trade overnight. The path forward requires a paradigm shift from pure efficiency to intentional redundancy in energy and food logistics. Infrastructure architects must prioritize resilience over cost savings for these specific sectors because they are the first line of defense against economic collapse during conflict scenarios. This means building strategic reserves, diversifying supply routes that do not rely on single choke points, and investing in decentralized generation capabilities that can operate independently if global trade halts. It is a trade-off that current investments have failed to prioritize compared to the perceived urgency of chip autonomy, but it is one we must make before the next crisis forces our hand at great cost. The world economy faces a trillion-dollar fault line not because of what Taiwan makes, but because of how little redundancy exists for what keeps us alive and powered during a conflict. Until we recognize that energy and food logistics are more fragile than high-tech supply chains in wartime conditions, any strategy to prepare for a potential confrontation will be built on sand rather than bedrock. The real strategic failure is not waiting too long to build chip fabs, it is assuming the world can function without oil or grain when the ships stop moving. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.